Alright guys and gals, let's do this. This is the moment you've all been waiting for. It is time to get into that fun-filled, action-packed, one-step equation, geometry, flipped classroom video. So this is pretty much just going to be a review because we want to make sure you have the foundations for success. Because in geometry, we are going to be using those algebraic concepts that you learned before. So let's make sure you know it. Later, we're going to be doing some examples towards the bottom of this. And if you know all the examples, if you're like, Coach Goo, Coach T, I know how to do this. I know how to do it already. Then you can just do all those on your own later. But first, let's make sure we get some common vocabulary that we'll be using in the classroom. So when I break out these math words, you aren't like, wait, what's Coach T? What language he's speaking? So first of all, let's get this first one. N something is a mathematical sentence with an something sign. So I'm just gonna give spoiler. Whoa, hold on, get out of here. Nice, so this one. An equation is a mathematical sentence with what sign do you think? If at any time you want to challenge yourself, pause the video so you can take a guess so I don't just spoiler the answer for you. Feel free to pause the video and try to fill in the answer and see if you get it right. Make it a little more fun for yourself. An equation is a mathematical sentence with a what sign? A plus sign? A minus sign? No, it's an equal sign. Equal sign. All right, so an example of a mathematical sequence would be 2x. Okay, 2x by itself is just an expression. It really doesn't mean anything because we don't even know what x is. But then we put equals 8. Now we know that both sides have to be equal because we have this equal sign here. You see that? 2x equals 8. And then that is a mathematical sentence. All right, next up here, what is this one going to be? A something of an equation. I'm going to give you a little answer right here. Solution of an, wait a second, hang on, that my O looks like a U, solution of an equation is a value for a variable that makes the equation what? False? Makes the equation wrong? No, it needs to make the equation true. Duh, come on. A solution of an equation is a value for a variable that makes the equation true. So for example, let's say you solve this, 2x equals 8. What do you think the answer is? I'm going to say, the answer is 4. So now we're going to plug it in. The solution is 4. Is it actually 4 though? So let's plug it in. So x equals 4, so let's plug in the 4. 2 times 4 equals 8. What's 2 times 4, y'all? What's 2 times 4? If you said 8, that's right. And does 8 equals 8? Is this true? Yes, it is. So our solution, we said, was 4. And that the value 4 for this variable x makes this equation, 8 equals 8, true. So in that case, 4 would be our solution, and x has to equal 4. Alright guys, and now, so there's that. So now we have 3 rules, and these rules apply all the time, okay? So when you solve an equation, your goal is to get the what alone by itself. What are you trying to get alone by itself? You're trying to get the variable alone by itself. That's the x or the y, that's the letter or what, I mean, it might be a symbol or something. But you're trying to get the variable alone by itself on one side. If you said one side, give yourself a high five actually. Let's just get a high five in there, In other words, you're trying to, I don't know if you're going to guess this one, but this one was isolate the variable. Isolate means get by itself. You're trying to get the variable by itself, okay? Rule number 2, when you're solving for a variable, you must use inverse operations. Inverse operations. What does inverse mean? Take a second and think about it. Inverse means opposite. Okay, remember guys, you can pause the video anytime to make it more entertaining for yourself and try to guess the answers. But if not, just let it play like normal. So inverse are opposite operations to isolate the variable on one side of the equation. Okay, and then rule number 3, this is the big one, okay? Don't mess up on this one, y'all. Whatever you do to one side of an equation, you must do to the other side, to the other side of the equation. In other words, you must keep the equation balanced, equal, balanced or equal. So these are the 3 rules, okay? When you solve an equation, your goal is to get the variable alone by itself on one side of the equation. In other words, you're trying to isolate the variable. Rule 2, when you are solving for a variable, you must use inverse operations to isolate the variable on one side of the equation. And rule number 3, whatever you do to one side of an equation, you must do to the other side of the equation. In other words, you must keep the equation balanced and equal. Alright guys, we're almost done with these notes here. So finally, the inverse operation for addition is, remember, what does inverse mean? It means opposite. So what's the opposite operation for addition? If you said subtraction, then you are right. Subtraction. Alright, next up, we have the inverse operation for multiplication. What is the opposite of multiplication? If you said division, then you are right. And last one, the inverse of an exponent. This one might be a little tough, but what's the inverse of an exponent? If you said root, then you are right. For example, if you have x squared equals 9, how would you get rid of this x squared? You're going to take the root from both sides. Remember, both sides, because if you square the left side, right side number 9, he's going to be like, that's not fair. He got a square. You got to square me too. So we square him, and then now we got x equals 3. All right, so that is going to be it for the vocabulary. So now let's hop into these examples. Oh, by the way, one more thing. What if you have x cubed equals 8? What would you do here? We don't use this very often, but it's kind of cool to know. Maybe, you could use a cubic root like this with a little 3 over here. That way you get x equals 2. And why is that? Cubic root, remember, is the same thing being multiplied 3 times. Oh, wait, it's not working like that. Equals 8. 2 times 2 times 2 equals 8. So there's that. All right, so let's go into these examples now. Okay, first one. Remember, if you already know how to do these, you can just close this video, go do it by yourself. Maybe you want to check your answers with the video so you don't mess up. But anyways, we're going to do these together now. So here we go. Let's do the first one. Example number 1. 170 plus x equals 200. Remember, what are we trying to do? Let's scroll up and check our notes. We're trying to isolate the variable. We're trying to get the variable or that letter, that x or that a, or that j. We're trying to get those by themselves. So let's get it by itself. How are we going to get it by itself? There's a 170 over here. What's it doing on this side? We're going to get rid of that by subtracting 170. But remember, whatever you do to one side of the equal sign, you can draw a little line here if that helps you. You got to do to the other side of the equal sign as well. So minus 170 on both sides. 170 minus 170 equals 0. So we got 0 plus x, which is just x, equals... What's 200 minus 170, guys? It's 30. So now we have 0 plus x, which is just x, equals 30. So x equals 30. If you want to check your answer, you can plug 30 back in for x. 170 plus 30 equals 200. Then you're right. X equals 30. Okay, next one. Example number 2. 15 equals negative 52 plus a. What do we got to do here to get this a by itself? It has a negative 52 over here, so we are going to... What do you think we're gonna? What did you say? Add 52? That's crazy talk. We're gonna add 52 to both sides. But wait, boom, that one's gone. And 52 plus 15 is 67. 67 equals a. There you go. That's number 2. Number 3. Let's go straight to it. 8j equals 128. Remember, if you have a number and a letters next to each other, that's the same thing as having over here 8 times j equals 128. What was the opposite of multiplication? Look up here, back up at your notes. It's in the orange on mine. Division. So we're going to do the opposite of multiplication, which is division. So we are going to divide by 8. Divide by 8. But we got to do it on the other side as well. So we divide. Boom. It's j equals. What's 128 divided by 8, guys? What's 128 divided by 8? It is 128 divided by 8 is 17. Alright guys, we're getting down to the wire. We only got 3 more let's try together, so we're almost here. Just hang in there, guys. Keep it focused a little bit. So now we got m divided by, or m over 10, but remember, if something's over something, that pretty much means division. So m divided by 10 equals 315. So what do we need to do? What's the opposite of division? If you said multiplication, you're on point. Times 10 times 10, both sides, because remember, we got to do what we do to one side to the other side. Times 10 times 10, that cancels this. So now we have m equals 3,150. All right, moving on into the next one. 225 equals p squared. Remember, what do we do to get rid of squared? If you look up here, the inverse of an exponent is the root. So we're going to do the square root on both sides, not just one side, because that would be wrong. And we're going to have this cancels the squared. So now we have P equals, what's the square root of 225, guys? What's the square root of 225? It is 15. All right, and now we're down to the last one. Well, look, if square rooting is the opposite of using an exponent, then what's the opposite? What do we got to do here? We have to square both sides. We're going to square both sides. That gets rid of this square root right here. Scribble, scribble, scribble. Now we have an x equals 11 squared. What's 11 squared? What's 11 times 11? That equals 121. So now we're going to put 121 here, and x equals 121. Whoa, we are finished, guys. That is those 6 example problems. So now the next 4 right here, it says now you try. I want you guys to try these 4 problems on your own, and then you can check your answers with a teacher. Remember, it can be any, if you want to go in for tutorials, you can check with any geometry teacher. But that's it for this fun-filled, action-packed Flip Classroom video. So until next time. Well, actually, I guess this time you're right here in my classroom, so it's not until next time. But normally you'd be watching this video while you're at home, so I see you the following day, so that would make sense. But I guess I can't really say that this time. But anyways, that's the end of this video. Try these problems on your own now, and if you have any questions, feel free to ask.